Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 13, Qawarizmi. Today we will share to you guys about a report review from an article, the investigation of the April 14, 2021 collapse of a bridge span under demolition, Herbert C. Bonner Bridge, the County, New Carolina. Okay, for the introduction part, based on the article, it appears that the collapse of the Herbert C. Bonner Bridge was a tragic incident that resulted in the loss of life. The bridge was undergoing demolition when the last span collapsed, killing an employee of PCL Civil Constructor. The span that collapsed was the navigation span of the bridge, which was 180 feet long, 20 feet wide, and approximately 60 feet above the sea level, with a total weight of 980 kips. The incident occurred on April 14, 2021 at approximately 5 p.m. in the county, North Carolina. The investigation into the collapse of the Herbert C. Bonner Bridge is ongoing, and the findings of the investigations will be critical in determining the cause of the incident. The collapse of the bridge is a stark reminder of the importance of safety in construction and demolition projects. In this report, we will examine the events leading up to the collapse of the bridge, the investigation into the incidents, and findings of the investigation. We will also discuss the implications of the incidents of the construction industry and the steps that can be taken to prevent similar incidents from occurring in the future. Okay, we go to the next, which is cause of the accident or disaster. Okay, from this report, it's identify reported causes as below. First, failure to follow established procedure. It is because the employee failed to follow the established procedures for the tasks they were performing. Especially, the employees did not follow the lockout, takeout procedures, which are designed to prevent the release of hazardous energy during maintenance and repair activities. Second, inadequate training. The employees lacked adequate training to perform the task safely. The employees were not trained on the lockout, takeout procedures, and they did not understand the hazards associated with the task they are performing. Last, lack of communications. There was a lack of communication between the employees and the supervisor. The supervisor did not communicate the hazard associated with the task to the employee, and also the employees did not communicate their lack of understanding of the task to the supervisor. We go to the actual root causes of the accident. First, inadequate safety culture. The company's safety culture was inadequate, which led to a lack of emphasis on safety and lack of accountability for safety. The company did not prioritize safety, and there was a lack of accountability for safety at all levels of the organizations. Second, inadequate training. The employees lack of adequate training to perform the task safely. The employees were not trained on the lockout, takeout procedures, and they did not understand the hazards associated with the task that they were performing. Last, inadequate supervision. The supervisor did not provide adequate supervision to ensure that the employees were following the established procedure. The supervisor did not verify that employees had followed the lockout takeout procedure and did not ensure that the employees understand the hazards associated with the task.
Assalamualaikum warahmatullahi wabarakatuh. So I wanted to talk about investigation of the April 14, 2021, which is collapse of a bridge span under demolition in NC. So I will talk inside of ethical issue and code of conducts. And my name is Najan Zulfakhar bin Muhammad Nasir. So ethical issue in bridge collapse. Contractors' failure to follow the demolition plan developed by the structural engineering firm, which is they not follow the structural plan and did not ask for permission for authorization, and they failed to address concrete deterioration of the product of the bridge spans that preventable accident due to inadequate planning and disregard for safety. Next, Code of Conduct for Engineers. Conduct of registered person. Engineers expected to act honorably, responsibly, ethically, and lawfully. Responsibility to employer, client, or profession. Discharge of duties with fidelity. Repetition of a registered person. Solicitation and advertising. Restriction on interfering with or taking on work. Next is importance of ethical standard, which is it can vital for integrity, professionalism, and safety of engineering firms. That is essential to prevent accidents such as bridge collapse. Adherence to standard crucial for maintaining public safety and the reputation of the engineering profession. In the conclusion, for safety of all the people that are related to construction site, they have to follow the code of conduct for preventing such incident and maintaining happen again. And ethical decision making is crucial in construction project to protect workers and the public. So make sure everybody follow the guideline well. So that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Yusuf. I will present about risk assessment and high rate. So I will start my presentation with risk assessment. Risk assessment is to ensure the safety of everyone involved and minimize potential damage. A comprehensive risk assessment must be carried out before carrying out any activity on or near a bridge. Here is a breakdown of potential risks and mitigation strategies that management should consider. Structural risk. Firstly is bridge integrity. Assess the condition of the bridge through regular inspection, paying close attention to crack, rust, and other signs of damage. Next is environmental factor. Consider the effect of weather conditions such as wind, rain, and snow. Next is operational risk. The first one is worksite safety. Implement strict safety protocol for bridge worker, including appropriate personal protective equipment, fall protection system, and emergency procedure. Next is material handling. Store and transport material and equipment safety to avoid falling objects or spill that could damage the bridge or injure worker. And the last risk is external risk. The first is natural disaster. Create an emergency plan for natural disasters such as earthquake, flood, and fire that may affect bridge stability. Next is collisions. Implement measures to prevent collisions with the bridge, such as installing guardrail, signal, and lighting. And lastly is emergency response. Establish a clear emergency procedure in the event of an incident, fire, or other incident. Next, we move to the hazard identification, risk assessment, and risk control, or HIRAC. So, if we can see at the slide is the table for likelihood or probability. The first likelihood is the most likely. The example is the most likely result of the hazard or event being realized. The rating is 5. The second likelihood is the possible, and the example is has a good chance of occurring and is not unusual. The rating is a 4. The next likelihood is the conceivable, might be occur at some times in future, and the rating is a 3. The next likelihood is the remote, has not been known to occur after many years, and the rating is 2. And the last likelihood is the inconceivable. The example is practically impossible and has never occurred. The rating is 1. Next, we move to the table for severity. So for the first severity is catastrophic. The example is numerous fatalities, irrecoverable property damage, and productivity. Next is fatal. Appreciate one single fatality, major property damage if hazard is realized. Next is serious. Non-fatal injury, permanent disability. Minor disability, but not permanent injury. And the last severity is negligible. Minor abrasion, bruise, cut, first aid type injury. Next, we move to the table for action matrix. For the color reds show the high risk, which is 15 to 25. Next is the color yellow, show the medium risk. So the risk is 5 to 12. And the lastly is the color yellow, show the low risk, which is 1 to 4. Next, we move to the hazard identifications. Firstly, bridge inspection and maintenance. The hazard is fall and which can cause cracks, rust, and other signs of damage. Material handling. The hazard is equipment failure and which can cause tool or equipment falling from the bridge, can injure worker below. Next is carry steel girders using crane. The hazard is falling objects which can cause serious injuries to worker. And the last activity is the welding and cutting. The hazard is a cutting blades which can cause cut or first aid type injury. Next, we move to the risk assessments. Firstly, safe work practice. For the likelihood is 4 and severity is 4. So for the risk is 16, show the high risk. Next is a safe work practice. Daily pre-use checks. The likelihood is 3 and severity is 2. The risk is 6, that means the medium risk. Next is training, safe work practice, and warning sign. The likelihood is 4 and severity is 4. So for the risk is show the high risk. And the lastly is always use personal protective equipment. and cover on button. The likelihood is 4 and for the severity is 3. And for the risk is 12. That means the medium risk. Lastly is the risk control. So the firstly is full protection such as harness and lanyards. Number 2, wear personal protecting equipment, emergency preparedness, and lastly is to make delay start button.
Assalamualaikum and greetings to Doctor. My name is Muhammad Aizat Shamim bin Mahyudin. I will talk about the discussion and conclusion for, for the article and also the overall conclusion for the article. First of all, this is the content of what I'm going to present. First of all, we got the risk assessment discussion. Second one, we got conclusion on avoiding reoccurrence. And the third is overall conclusion. And four, I will share the reference where I got the article from. And firstly, we'll talk about the risk assessment as a discussion. First of all, this is the four risk assessment that I could find in the article. Being the first one is the project management risk, second being structural engineering risk, safety protocol risk, and lack of contingency plan. First of all, we will go into the project management risk, and we need to take a look at the deviation from approved plans. Failure to adhere to approved demolition plan leads to a significant risk, compromising sequential span removal and causing structural instability. And secondly, inadequate communication. Poor communication among stakeholders such as PCL, NCDOT, and KCI about plan changes, debris storage, and operational modification introduce uncertainties, which would escalate the risk of error. Next, we have structural engineering risk. Firstly is independent demolition plans. PCL's decision to create independent demolition plans without engineering evaluation pose a substantial risk, contributing to the overloading of structural members. Secondly, the failure to follow demolition sequence, which non-compliance with the specified demolition sequence, such as removing overhang and parapets in the wrong order, would introduce unnecessary stress on the structure. Next, we will look into safety protocol risk. Inadequate oversight lead to collapse of span 145 exposed a lack of oversight during critical demolition stages. Non-consistent adherence to safety protocols and conditions specified by KCI resulted in compromised safety. Next, we have a lack of contingency plans. The absence of contingency plans for unforeseen challenges, particularly in debris storage, highlighted a gap in risk mitigation strategies, which contribute to the project vulnerabilities. And for the second part, we will go to conclusion on avoiding reoccurrence of the tragedy from happening again. Firstly, the conclusion on avoiding recurrence is the adherence to approved plan and enhance communication and collaboration between within the workers, engineering, higher up and lower, and the down workers, and so on. And a thorough engineering survey is also crucial, as without a thorough survey, the the plan would not be very secure. And continuous oversight and monitoring is as crucial as the other stuff, This is because any projects needs almost 24 hours monitoring to ensure that uh, the risk of the unwanted tragedy could be lessened. And contingency planning, which is also crucial, as also the same as the education and training. The high education workers is needed, and for the project to be so that the project could be planned very goodly. And training could also increase the workers' experience, as some of the workers may have never do the related project. And lastly, we have industry-wide collaboration. This part actually I want to talk about uh, uh, the project company needs to consider others industrial ideas to provide more more questions. This question is actually about the risk. What is the risk that could have that the project could have if and so on. And next, we will go to the overall conclusion for the article. Now, in my opinion, the from my review, the collapse of the Herbert C. Bonner bridges last spent during the mission in Dare County, North Carolina, resulted in a tragic fatality and prompted a thorough investigation by OSHA or OSHA. The finding also reveals critical lapses in the demolition processes conducted by PCL Civil Contractor Incorporated. Despite the presence of an approved demolition plan, PCL deviated significantly, altering the sequence and disregarding key safety measures outlined by the plan. The failure to follow engineering guidelines, staking concrete debris on the deck, and premature cutting of supporting girders led to structural overloading, culminating in the collapse of the navigation span. The incident underscores the importance of adherence to approved plans and rigorous engineering assessment in the mission project, emphasizing the need for strict safety protocols to prevent such strategies. And next, I will show you the reference, which is where I got the what we call the article from. And I think that's all from us. Thank you very much.